fellow castaway are stranded on a desert island, playing dice for the last banana. You've agreed on these rules. You'll roll 2 dice, and if the biggest number is 1, 2, 3, or 4, player 1 wins. If the biggest number is 5 or 6, player 2 wins. Let's try twice more. Here, player 1 wins. And here, it's player 2. So who do you want to be? At first glance, it may seem like player 1 has the advantage, since she'll win if any one of 4 numbers is the highest. But actually, player 2 has an approximately 56% chance of winning each match. One way to see that is to list all the possible combinations you could get by rolling 2 dice, and then count up the ones that each player wins. These are the possibilities for the yellow die. These are the possibilities for the blue die. Each cell in the chart shows a possible combination when you roll both dice. If you roll a 4 and then a 5, we'll mark a player 2 victory in this cell. A 3 and a 1 gives player 1 a victory here. There are 36 possible combinations, each with exactly the same chance of happening. Mathematicians call these equiprobable events. Now we can see why the first glance was wrong. Even though player 1 has 4 winning numbers and player 2 only has 2, the chance of each number being the greatest is not the same. There is only a 1 in 36 chance that 1 will be the highest number, but there's an 11 in 36 chance that 6 will be the highest. So if any of these combinations are rolled, player 1 will win. And if any of these combinations are rolled, player 2 will win. Out of the 36 possible combinations, 16 give the victory to player 1, and 20 give player 2 the win. You could think about it this way, too. The only way player 1 can win is if both dice show a 1, 2, 3, or 4. A 5 or 6 would mean a win for player 2. The chance of one die showing 1, 2, 3, or 4 is 4 out of 6. The result of each die roll is independent from the other, and you can calculate the joint probability of independent events by multiplying their probabilities. So the chance of getting a 1, 2, 3, or 4 on both dice is 4 out of 6 times 4 out of 6, or 16 out of 36. Because someone has to win, the chance of player 2 winning is 36 out of 36 minus 16 out of 36, or 20 out of 36. Those are the exact same probabilities we got by making our table. But this doesn't mean that player 2 will win, or even that if you played 36 games as player 2, you'd win 20 of them. That's why events like dice rolling are called random. Even though you can calculate the theoretical probability of each outcome, you might not get the expected results if you examine just a few events. But if you repeat those random events many, many, many times, the frequency of a specific outcome, like a player 2 win, will approach its theoretical probability. That value we got by writing down all the possibilities and counting up the ones for each outcome. So, if you sat on that desert island playing dice forever, player 2 would eventually win 56% of the games, and player 1 would win 44%. But by then, of course, the banana would be long gone.